part 2 of the Honors Algebra 2 placement exam for Marymount. Starting with number 45, we have systems of equations, and this time they are inequalities. So we have two lines here. These inequalities represent two lines, and we want to know where do they share solutions. So both inequalities are in slope-intercept form. So the slope of this first inequality is -5 halves, and the y-intercept is -3. So we'll graph that. We don't have to do anything. We can just go to the -3. It is equal to, it is greater than or equal to. So we're going to have closed circles. Then we're going to use the slope, which is down 5, right 2. Or we can go up 5, because we go off the graph. We can go up 5, 1, 2, 3, 4, 5, and left 2. We're going to have a solid line for that border. And then we're going to test a point. Always easiest to test. We're going to test 0, 0. And we'll plug those values in to see if that point is true or false. 0 is greater than -3, so that point, 0, 0, is a true point. So if this point is true for this blue line, then every point on this side is going to be true for the blue. We'll do the same for the green. Let's look and see what the slope for the green. The slope is 1/2. The y-intercept is 3. So we'll graph this one in green pen. So I'm going to go to my y-intercept. That is open circle because it is just less than. And then we go up 1, right 2. Up 1, right 2. We're going to do, I do a dotted line. I don't know if that is universal in all math. It should. And then we're going to test 0, 0 again, but we're going to test it for the other equation. So 0 is less than 1/2 times 0 plus 3. Is 0 less than 3? Yes, that's true also. So that point 0, 0 is true for the green. So every point on this side of the green, if this point is true, then every point on this side is going to be true. So where is it true, true? That's the question. So it is false for the top equation, false for the bottom equation in that quadrant. It is true for the top equation, but false for the green equation. It is false for the blue, but true for the green. And in here, in this area, this is where it's true, true. It's the double shaded. Double shade meaning true, true. Now, on this border, that green border is false. All those values on that green border are considered false, hence why it's an open circle and dotted. So that's a good way of showing where it is. Okay. Indoor climbing gym is a popular field destination, field trip destination, sorry. And this year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 4 vans and 2 buses with 78 students. High School B rented and filled 6 vans and 12 buses with 360 students. Every van had the same number of students in it as did the buses. Find the number of students. So if we're going to look at School A and School B, we can write a vans plus buses equal the total number of students. So we have 4 vans plus 2 buses equals 78 students for High School A, and High School B had 6 vans and 12 buses. Sorry, yes, I know you said, why did he write another V? Because I made a mistake. Good. Now we have systems. We have 2 equations representing 2 variables, and we can use systems of equation. I'm going to use elimination, but they don't naturally eliminate, so I'm going to have to use multiplication, and I'm going to multiply this top equation by -6. That creates a new equation. That's negative 24v minus 12b equals, what's 78 times 6? Gives me 468. 468 negative. And then I'm going to just bring my original equation over. 6v plus 12b equals 360. And I'm going to combine them. I'm going to add them together. I'm going to add this column, which gives me negative 18v. We notice that our column for the buses cancel, hence why it's called elimination. We've eliminated one of the variables. So that cancels to 0, equals, and then we're going to combine the constants over there. And negative 468 and 360 gives us negative 108. Gives us negative 108. And I'm going to divide both sides by negative 18. And we get vans equal 108 divided by 18 gives me 6. So there are 6 students in a van. For each of those vans has 6 students in each of the vans. And then I can take any of those equations. We're just going to take the first one, 4v plus 2b equals 78. And we're going to substitute in for v equals 6 plus 2b. And notice we did that because now we only have one variable. 24 equals 2b equals 78 minus 24. We get 2b equals 54. Divide by 2, divide by 2, b equals 27. So there are 6 students in a van and 27 students in a bus. Cool. That's a good one. Yep, I like that one. Simplify your answers. Very important here in this first problem. We're going to simplify, and we're going to simplify by distributing this exponent. You can distribute exponents across multiplication. I don't like the fact that that doesn't do that, so I will choose a different. So we're going to distribute that to each term or each entity inside. There's a -1 there, so we have -1 to the 5th, and then we have y to the 5th to the 5th. Power over power, we're going to multiply their exponents times, and we're going to distribute again. We're going to distribute this 2 to the 2, to the x, and to the y. So that gives me 2 to the 2nd times x to the 2nd times 2 times y to the 4th times 2. We take a power of a power. We can distribute when the item inside the parentheses is being multiplied, and then when we have a power of a power, we multiply their exponents. -1 to the 5th is -1. Any negative number to an odd power will stay negative. That's going to be y to the 25th times 2 to the 2nd is 4, x to the 4th, y to the 8th. We can combine like terms or like bases. When we multiply like bases, so different from exponents, it's different from a power to a power. When we multiply like bases, we add their exponents. So we're going to combine these constants, which makes -4. We have x to the 4th, y to the 25 plus 8. When we write our variables, we're always going to write in alphabetical order. So we have -4, x to the 4th, y to the 33. All right, there's some good technical stuff there. The answer key on Marymount's answer key is incorrect. You should always put your variables in alphabetical order within its term. That is what we call standard form. So we have a universal answer across everywhere. So we're going to take this exponent, we're going to distribute it. We have -1 to the -1 power. We have y to the 3 times -1. We're going to take, this is not a parentheses, so these are two distinct separate terms. So technically we have y times x to the -2nd. So 1 to the -1. Negative exponents, you can't simplify negative exponents. You have to get rid of the negative in front of the exponent. The way we get rid of it is you take the reciprocal. So in this case, it's in the numerator, it's going to be in the denominator. So this is technically equal to this. And this becomes y to the -3. And these are still, we can switch this one now. So this is going to be 1 over x to the 2nd. So we notice that we got rid of this negative exponent by moving the base and the exponent into the denominator. It was located in the numerator, it now goes in the denominator. We're going to do that for this one also. We'll take, in order to get rid of that negative exponent, we're going to take its base and its exponent, and we're going to move it into the denominator. We can simplify -1 to the 1 is -1. Y to the -3rd is 1 over y to the 3rd. You notice the base and the exponent stay. It's just the location that we've changed. That is y, and that is 1 over x to the 2nd. So 1 over -1 is -1. We have a y in the numerator is going to cancel with one of the y's in the denominator. And so we'll have -1 over y to the 2nd. And then we have x to the 2nd. Now I can't leave that as my answer because my variables are not in alphabetical order. So you can have that as an answer, or you can have 1 over -x squared y squared. Either of those answers is acceptable. I would not, Mr. Mack would not accept those variables to be, I would not accept y to the 2nd, x to the 2nd. But either of these is okay. It doesn't matter where the negative is. Negative just tells us direction. All right, simplifying. So we're subtracting these two. We can't combine these because they're in parentheses. How do we get rid of the parentheses? Well, we're going to distribute this negative into this parentheses. Once we distribute it, Chewbacca goes away. So we get 1 minus 6r to the 3rd minus 13r to the 4th minus 10 plus 12r to the 3rd. Let's put it in descending order per its variable. So you have negative 13r to the 4th minus 6r to the 3rd plus 12r to the 3rd plus 1 minus 10. Constants go at the end. We have like terms here. Negative 13r to the 4th plus 6r to the 3rd minus 9 would be my final answer. Also standard form, very important. Same thing, we're subtracting these two. We have parentheses, so we have to, how do we get rid of the parentheses? By distributing out that negative. 11b to the 5th plus 4b to the 2nd is unaffected. And then we distribute that negative. That becomes positive b to the 5th minus 3b minus 2b squared. And now I would put it in order. I have 11b to the 5th plus b to the 5th plus 4b squared minus 2b squared minus 3b. We have like terms and like terms. That makes 12b to the 5th plus 2b squared minus 3b. Descending order, since they have the same variable, we look at their exponent. So b to the 5th is going to come before b to the 2nd, which will come before b. And that looks good. Next one. We have the product of two binomials. So we're going to use what we call FOIL, first, outer, inner, last. The first, We're multiplying the first term times the first term, 5n times negative 4n. That's first. Outer, these are the outer two terms. This is the outer and this is the outer two. So we're going to multiply 5n times 7. Inner is the inside 2, the inside inner 2, so that's 2 times negative 4n. And then the lasts. These are the lasts, so I'm going to multiply the lasts of each of the terms. So that's positive 2 times positive 7. 5n times negative 4n. 5 times negative 4 is negative 20. N times n is n squared. 5 times 7 is 35. N. 2 times negative 4 is negative 8n, and 2 times 7 is 14. We have like terms, so we're going to combine their coefficients. 35n minus 8n is positive 27n. Yep, plus 14. And that would be our final answer in standard form. So make sure that you are putting n squared before n in your constant. Again, FOIL first. I also call this double distribution. You take each term and you distribute it. So I'm going to distribute 8x to negative 2x, and I'm going to distribute negative 8x to negative 5. And then I'm going to do my second distribution. I'm going to distribute 2 to negative 2x and 2 to negative 5. So you'll hear me say FOIL or double distribution. Negative 8x times negative 2x. Negative 8 times negative 2 is 16. X times x is squared. Negative 8x times negative 5 is positive 40x. 2 times negative 2x is negative 4x. And 2 times negative 5 is negative 10. My inside two are going to be like terms. That leaves me with positive 36x minus 10. Now these are not in standard form. The variable should come before the constant, but they are what we call conjugates. Conjugates are identical with opposite middle signs, but we're still going to do a double distribution. 6 times 6 plus 6 times negative 4x, and then we're going to distribute the 4x to the 6 and the 4x times the negative 4x. That gives me 36 minus 24x plus 24x minus 16x squared. You'll notice that my inside and outside terms are opposite of each other. So we get 36 minus 16x squared. Now I again would not leave it like that, and I would rewrite it like this, standard form. But you'll notice that when you multiply conjugates, the inside and the outside will be opposite of each other. We have positive 24x and negative 24x. So our inside and outside from FOIL, our inside and outside end up being opposites of each other. So you're just left with the first times the first and the last times the last. The more you do of that, these are conjugates. So I know my inside and my outside are going to cancel. So I'm just going to multiply my firsts and I'm going to multiply my lasts, which are these two. So you can do it that fast. You get x squared minus 4. You're always going to get a binomial, or you're always going to get the difference of two squares. The difference of squares. So when you multiply conjugates, they always produce the difference of two squares. You see it's the difference, the subtraction of two squares. X squared is a perfect square and 4 is a perfect square. Factor the common factor out of each expression. So we're going to look at each of the terms. There are 3 terms here, and we're going to look for a common factor. We're going to look at the coefficient, So we will look at negative 24, negative 15, and positive 30. And then we will also look at the variable, n to the fourth, n to the third, n to the second. So looking at the coefficient, what is the largest number that is divisible into negative 24, negative 15, and positive 30? One thing that we should take note is our first term is negative. Whenever your first term is negative, you must factor out a negative, no matter what the other terms. So we're going to factor out a negative, and I'd say 3. 6 doesn't go in. Yeah. So I'm going to factor out a negative 3 as my coefficient, and then I'm going to look at my variables, n to the fourth, n to the third, n to the second. The most I can take from all of them is 2, because this doesn't have more than 2, so I can't take more than 2, but I can take 2 from each of them. So if I factor out, aka divide this into each of those, I get 6n squared. I get plus 5n, and I get minus 10. So factor the common factor. This is my common factor. When I pull it out, it gives me 6n squared plus 5n minus 10. And we can check to see, is there still a number that goes into 6, 5, and 10? No. Is there still a variable that goes in? No, because this doesn't, negative 10 doesn't have a variable. So that's my quick check, and that would be my answer. So factor completely. So there is not a common factor. So now we go to factoring. Now we're going to try to look and see. First thing you should always, is it in standard form? Is it in descending order? Number 2, is there a common factor? No common factor from 7, negative 55, and 42, and there's no common variable amongst the 3. Next thing, is it a special case? Is it a binomial square, or is it the difference of squares? Binomial square always has 3 terms. The first and third are perfect squares, and the middle equals the square root, 2 times the square root of the first times the square root of the last. So there are going to be multiple characteristics that we would look to see. If those were true, then we would know it's a binomial square. It does have 3 terms, but my first and third are not perfect squares. So it's not a binomial square. Difference of squares. Is it subtraction? Is it 2 terms? Sorry. Is it 2 terms is the first thing. It's 3 terms, so I know it's not difference of squares. So the next factoring thing that I'm going to do is a times c. So my a value is 7 because we are looking at this as ax squared plus bx plus c. So when I say a times c, this is my a value, this is my c value. So 7 times 42, which gives me 294. Yes. Now I'm going to find factors of 294. Oh, I already see what it is. Well, it's going to be 1 and 294, but I'm going to get to 7 and 42 is going to be my solution. So 42 is a product. Remember, what we're doing is we're looking for the 2 binomials. Well, it can be something of this nature. It can be this, it can be negative, negative, it can be positive, negative, or it can be negative, positive with variables, right? A, B, C, D. So we're trying to figure out the combinations of these 2 binomials that produces this trinomial. So we know that we get this through FOIL. And to get this, this is the product of the lasts. So if it's a product and it ends up being positive, I know that my signs are the same, because the only way you multiply 2 numbers and get a positive is if they're both positive or if they're both negative. And the way we do this, first, we look here first. If it's a positive, I know my signs are the same. And then if I want to find out if they're both positive or negative, I look here. So they're both negative. So I know that my signs are going to be both negative. So negative 7 and negative 42, oh, that gives me negative 49. That does not make negative 55. So I am not done. Let's try negative 6 and negative 49. Yes, that gives me negative 55. So when I combine those, I'm looking for factors of 294, which is going to be a lot. But I'm going to, because I'm a little bit more proficient at it, instead of going through all the factor pairs, which would have been 1 and 294, 2 and 147, 3 no, oh, 3 yes, 3 goes into that, 9, 98, 4, does 4 go into that? No. 5, no. 6, yes, 6 and 49, as I said. 7, yes, 7 goes into that. 42 times 8, no. 9, no. 10, no. 11, no. 12, yes, 12. No, not 12, sorry. 14, yes. 14 and 21, and then I think that's it. So those are all the factor pairs, and then I would do the signs, and I would combine them. And what I'm looking for is negative 295. I should have just taught it this way. Instead of skipping, I'm kind of assuming that you know what you're doing here, but there are going to be some students who are not proficient at this. 135, negative 35. So we're looking to see which one of those is equal to my middle. And that's why I knew it was going to be negative 6 and negative 49. So I'm going to take this trinomial and I'm going to rewrite this into 4 terms. I didn't change the value. It's still the same thing because negative 6v and negative 49v equals negative 55v. I haven't changed it one bit. That's still equal to that trinomial above it. But I'm going to factor by grouping. And I'm going to group the first 2 and I'm going to group the second 2. I'm going to look for a common factor. What is the common factor here? Well, they both have a v. So if I take a v from that, that leaves me with 7v minus 6. And then I'm going to look for a common factor here. And since my first term is negative, I got to factor out a negative, and both 7 goes into both of those. So if I divide into negative 7, I get 7v minus 6. I know I did it right when my parentheses, my binomial is the same. Since it's the same and they're multiplying those terms, I'm going to pull it out. I'm going to factor it out. And what does it leave me with? It leaves me with v minus 7. And that will be my other binomial. And that is how we factor. That was totally long-winded, crazy, but you're going to have to go look at one of my other videos, A times C video on Mr. McCausland's YouTube to see the whole thing written out, because this video is going to be long to begin with, and that would make it even longer if I went through all that stuff. So I will show you, hey, standard form. Yes, it's in standard form. Is there a common factor? In this case, there is a common factor. We can factor out a 2, I think. 3. We can factor out a 3. Can we factor out a 6? We can factor out a 6. Sorry, that's our largest. That's our GCF is 6, common factor. So that gives me 3v squared plus v minus 30. I think that's correct. Good. And now we are going to factor this. So we're going to go back. Is it in standard form? Is there a common factor? No. So we're going to go to step 3. Is it a special case? Is it a binomial square? Nope, because the second sign is not positive. Is it difference of square? No, because it's not 2 terms. So we're going to use A times C. My A is 3. My C is negative 30. That gives me negative 90. I'm going to find factors of 90, 1 and 90, 2 and 45, 3 and 30, 4, no, 5, yes, 5 and 18, 6, yes, 6 goes into that, 6 goes 15, 7, no, 8, no, 9, yes, 9 and 10, and now we're done. So let's look. What are my signs? This is a product, so the only way I can get a product is when the signs are different. So it's positive and negative. So I know that my signs for my factors in this area here are going to be different. And I look here, and the bigger of the two is positive. So I have these two numbers, 1 and 90. I know the signs are going to be different. And the bigger of the two, 1 and 90, is going to get that positive. So 90 is going to get the positive, 1's going to get the negative. 45 is going to get the positive, 2 is going to get the negative. The bigger is always going to be on the right side, and the smaller is going to be on the left. So this gives me 89, this gives me 43, this gives me 27, this gives me 13, this gives me 9, this gives me 1. Which one of these is equal to my middle? My middle is positive 1. So I know that these two numbers are going to be the numbers that I split my middle. So I have my 6, I have my 3v squared, and instead of writing v, I'm going to write my two values, which was negative 9v and 10v. That variable is always going to be the variable of my middle, minus 30. And now I'm going to factor by grouping. I'm going to group in twos. So I have 6. Now 3v squared minus 9v, I can factor out a 3v. That leaves me with v minus 3. 10v minus 30. My first term is positive, so I'm going to factor out a positive 10, and I get v minus 3. I did it correctly because these are the same. That was my recognition. And so I have my 6 out there. I have my v minus 3. And then if I take the v minus 3, I'm left with 3v plus 10. 3v plus 10. Easiest, best method in factoring. Promise you that. All right. First thing, remember, is it in standard form? No. So we would have to rewrite this. Now it's in standard form. Is there a common factor? Nope. Is it a special case? Remember, binomial square has 4 things, 3 terms. This has 3 terms. First and third are perfect squares. Yes, x squared is a perfect square and 1 is a perfect square. Is my second sign positive? Second sign positive. Yes, my second sign is positive. And the last one, the hardest one, does the middle value equal 2 times the square root of my first times the square root of my last? So does my middle, which is 2x, equal 2 times the square root of x squared times the square root of 1? Does 2x equal 2 times x times 1? Yes. 2x equals 2x. So that is true also. So that means it's a binomial square. So this is going to turn into a binomial square. How do I get my first term and my second term? Well, I'm going to take the square root of the first, I'm going to take the square root of the last, and I'm going to pull down that sign. So my answer, factored, is the quantity of x plus 1 squared. Okay, it's in standard form. There is no common factor. Is it a binomial square? Is it a special case? We start with binomial square. 3 terms, yes. First and third perfect squares, yes. Is second sign positive? Yes. Is my middle 18p equal 2 times the square root of 81p squared times the square root of 1? 2 times 9p times 1? Yeah, it is. So, ding, 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 ding. So, I know it's going to be a binomial square. I take the square root of my first, which is 9p, take square root of my last, which is 1, and I bring down this sign. So see how easy it is to factor binomial squares. All right, this has 4 terms, so we're going to go through the process. Is it in standard form? U comes before V. Yes, good. Is there a common factor? Nope. Is it a special case? Is it a binomial square? No, because that has 3 terms. Is it the difference of squares? No, that has 2 terms. Can I do A times C? No, A times C is only with 3 terms. So my 5th one is factor by grouping. So I have 4 terms. Remember, in my A times C, I kind of did this too. So I'm going to look at the first 2. What can I factor out? I can factor out a 3u. That leaves me with v minus 8. And in my second, notice, first term is negative. So I'm going to factor out a negative 8, and I get v minus 8. Did I do it correctly? Yes, because what's inside the parentheses are the same. Let's pull that out. And what does that leave me with? That leaves me with 3u minus 8. 3u minus 8. And that's a nice way to factor a 4-term expression. Now, we take all that and we are going to start solving for the variable when the variable is being squared. So first thing I'm going to do is I'm going to try to isolate, since I only have 1 variable, I'm going to isolate the variable. We get 64n squared equals 16. We're going to divide both sides by 64, and we get n squared equals 16 over 64. You would want to reduce that, simplify all fractions, and we get 1/4. And now I have to get n by itself. It's being squared. What's the inverse of squaring? Square root. So a square and a square root will cancel each other. So that leaves me with n. Whenever we take the square root of a variable, we have to introduce plus or minus, and we get the square root of 1/4. Now, I can separate those radicals. And because it's division, we can separate radicals when they're being multiplied or divided. Square root of 1 is a perfect square, so I get 1. Square root of 4 is also a perfect square, so we get 2. So we get plus or minus 1/2. And that really means negative 1/2 and positive 1/2. But this is a nice high school way of writing those 2 values, plus or minus 1/2. Let's keep going, taking the square root, so we're still adding. 8v squared equals 208. Divide by 8, we get v squared equals, what's that going to be, 16? No, 2, 3, yeah, 16. So 16 is 48, and that's 6. So it equals 26, I think, yeah. 208 divided by 8. 208 divided by 8 gives us 26. Good. Now we're going to take the square root. What gets rid of a square is a square root. The square root and the square cancel each other. We're left with v equals, remember, whenever we take the square root of a variable, we introduce plus or minus, the square root of 26. We would have to check the factors of 26 to see if there are any perfect squares inside it. That's how we simplify radicals. But that is 2 times 13, and neither are perfect squares. So my solution is going to be plus or minus rad 26. That's good. They created a irrational. They gave us an approximation in the answer key, which I disagree with, especially since it didn't say round or convert to a decimal. This is an exact value, square root of 26. If I did 26 square root, we get this irrational number, a number that doesn't terminate and doesn't repeat. And we can't write that as an exact value. The exact value is square root of 26. So I like exact ones. All right, we're still taking the square roots. We're going to divide both sides by -9. We get x squared equals 144 over 9. We're going to take the square root of both sides. We get x equals plus or minus. I'm going to make that rad 144 over rad 9. We should recognize our perfect squares. At this stage, we should be able to see, oh, that did simplify, 144. So I could have actually simplified that fraction, but we're going to simplify it here so we can still be able to get away with it. So my solution is plus or minus 4. But we should recognize perfect squares. By taking the square root, we're still taking the square root. X squared equals, what's that, 16. Square root, x equals plus or minus 4 again. You gave me plus or minus 4 twice. That's kind of lame. You should be looking at your problems. All right, solve each equation by factoring. So remember how 1 was standard form? When it's an equation, it's going to be set equal to 0. That's always going to be your first step. So we're going to subtract 30. You get n squared plus n minus 30 equals 0. And then we're going to look at this expression over here. And we're going to factor it. We're going to try to factor it by, is it in standard form? Yes. Is there a common factor? No. Is it a special case? No. Second sign is negative, and it's not two terms. So we're going to do a times c. A is 1, c is negative 30. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4 no, 5 and 6. Signs are going to be different. And the bigger is going to be positive. So positive, negative, positive, negative, positive, negative, positive, negative. That gives me 29, 13, 7, 1. Which one's equal to my middle? Negative 5 and positive 6. So we get n squared minus 5n plus 6n minus 30 equals 0. Let's factor by grouping. We can factor out an n. We get n minus 5. We can factor out a 6. We get n minus 5. Pull out the n minus 5, which leaves us with n plus 6 equals 0. We're going to use the 0 property. 0 property says, hey, if we have two unknowns and we're multiplying it and get 0, well, one of these must be 0. One of them must be equal to 0. So I'm going to set each binomial equal to 0. So we want to know what is the n value that would make that box 0, and what is the n value that would make that box 0. Add 5. So if n equals 5, it would make this box 0, which would make the product equal to 0. And we would subtract 6 here, and we get n equals negative 6. If n was equal to negative 6, it would make that box 0, which would make the product equal to 0. Because the only way you can get 0 through multiplying two numbers is one of them must be 0. So our solutions to this equation are negative 6, 5. Again, numerical order when you give them. So it's negative 6 or 5. If we plugged negative 6 in, we would get it to equal. So negative 6 squared plus negative 6, does that equal 30? Well, the quantity negative 6 squared is 36 minus 6 equals 30. Yeah, so 30 equals 30. And if we did it for 5, 5 squared is 25, plus 5 is 30. So those are the two solutions. So some equations can have multiple solutions. So first thing is set equal to 0. We're going to subtract 14 from both sides. K squared minus 5k minus 14 equals 0. we're going to, is it in standard form? Yes. Is there a common factor? No. Is it a special case? No. A times C. A is 1, C is negative 14. Factors of 14 are 1 and 14, 2 and 7. Signs are different. Bigger is negative. So this time the signs are different, but this time the bigger is negative and the smaller is positive. So we get negative 13 and negative 5. These two end up being mine. And with this program that your teacher uses to create this, this placement exam, I have found that it always produces the bottom two, which is really bad. So you would really need to be particular if you want it to be other than the first or the last factor pairing, but it's okay. K squared plus 2k minus 7k minus 14 equals 0. Factor out a k, we get k plus 2. Factor out a negative 7, we get k plus 2 equals 0. Pull out the k plus 2, which is in both of them, and that leaves you with k minus 7 equals 0. Product of two numbers that equals 0, one of them must equal 0. Minus 2 is one solution, positive 7 is the other. So I'm going to write it in a solution set in numerical order, and that's that. You should be doing these problems that fast. You should have done them since 8th grade, since you were proficient and you're in honors. You should know how to factor that fast. Quadratic formula. You should also know what the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Again, understanding that you are in quadratic form, which is ax squared plus bx plus c. That's where you get your a, b, and c values. But the first thing you have to do is set it equal to 0. So I'd subtract 32 from both sides. We can think of this formula with 0p. That would be our b value. So we get x equals the opposite of 0 plus or minus 0 squared minus 4 times my a value, which is 2, times my c value, which is negative 32, all over 2 times my a value. So we get x equals plus or minus the square root. Negative 4 times 2 is 8. 8 times 32 is 16, 25, 256. I like that because that's a perfect square. So we get plus or minus rad 256 over 4. What's that? 13? 16 maybe? What did I say? What am I doing? 256. 256 square root 16. So we get x equals plus or minus 16 over 4. So we get plus 16 over 4 and negative 16 over 4, which gives us 4 and negative 4. So my solution is plus or minus 4 for probably like the 11th time on this worksheet. With the quadratic formula, so I'm going to set it equal to 0. I'm not going to move this. My a always needs to be positive when using the quadratic formula. So I'm going to move the 2 over, and I'm going to move the 5x over, because you have to set it equal to 0. Minus 5x minus 2 equals 0. My a is 3, my b is negative 5, my c is negative 2. So we're going to use the quadratic formula. B squared minus 4ac all over 2a. Opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So that's 5 plus or minus 25 plus 24 over 6. So 5 plus or minus square root of 49 over 6. 5 plus or minus 7 over 6. It's kind of fun. We get to see 5 plus 7 over 6, 5 minus 7 over 6. That's what the plus or minus means. That gives me 12 over 6, which is 2. This gives me negative 2 over 6, which is negative 1/3. So my two solutions are negative 1/3 and 2. Put them in numerical order. All right, now we're talking about radicals. The outside term can stay there. I can separate these under each of their own radicals because they're being multiplied. If they were being added and subtracted, I would not be able to separate them into their own radicals. Since 360 is not a perfect square, I'm going to break that up into those two numbers, and that allows me to break it up to this. Why did I pick 36 and 10 instead of 2 and 180? Because 36 is a perfect square, and I can simplify that. So that would give me 6. It'd come out of the house, and rad 10. Now, x to the 5th, I'm going to break this into x squared, x squared, x squared. Just think of it in that manner. Because remember, what's going to get rid of a square root is a square. So that's going to be square root of x squared, square root of x squared, square root of x. That's going to produce an x. That's going to produce an x. And I'm going to be left with a rad x. Square root of y squared is y. So let's bring that down. And now let's keep all the things on the outside. My constants makes negative 24. I got x times y, which is x squared y. And now I have things that are still in the radical. So rad 10x. Rad 10x cannot be simplified any further. The things that have come out always go first. The things in the radical always go second. 7 rad 210 times rad a. 7 210. Is there perfect square factors? So I'm looking at perfect squares. Perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81. So we're looking for any of these numbers that go into that. You get, well, we can also think of what that produces, right? That's 3 times 7 times 2 times 5. That doesn't simplify because there are no perfect squares. So that's just going to be that. 7 rad 210a. That cannot be simplified. That's actually not a bad question. I don't mind this. Find the distance between each pair of points. There's two ways we can do it. We can put it on a coordinate, 1, 2, 3, 4, 5, 6, 1, which would be there, and 0, 1, which would be here. And then we could create a right triangle. We can create a right triangle, and that distance between it would be the hypotenuse. So we can use the Pythagorean theorem, which would be that. What is the sides or the legs of it? So it's 2 squared plus 6 squared equals c squared, or the hypotenuse. So that's 4 plus 36, which is 40, equals c squared. We can take the square root of both sides, and we get rad 40. Rad 40 equals c. And we don't do plus or minus with this, Mr. Mack. We took the square root of a variable being squared. Yeah, well, we're talking about distance, so we can only come out with positive distance. This can be simplified, so this becomes 2 rad 10. That is one of the ways to do it. Another way we can do it is we can use the formula. There is a formula that we have. Let's clone the page. Let's erase the ink. Clear ink. So that is distance equals the square root of x sub 2 minus x sub 1 quantity squared plus the quantity of y sub 2 minus y sub 1 quantity squared. And that's just finding the distance between the x values. And that's our a squared plus b squared equals c squared. And we solve for c by taking the square root of that. So we could use that formula also. D equals the square root. This is x sub 1, y sub 1, x sub 2, y sub 2. The sub means 0.1 and 0.2. So we have 0 minus 6 quantity squared plus 1 minus -1 quantity squared. So we get d equals the square root of -6 squared plus 2 squared. And hopefully you see the similarities. We get 36 plus 4. D equals the square root of 40. And that simplifies to rad 4 rad 10. D equals 2 rad 10. So that's the distance formula. Find the midpoint. Midpoint is same exact thing, but you're going to divide it by 2. So I think it's like the midpoint equals, oh yeah, it's the sum of the 2 divided by 2. So it's midpoint equals x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. That's what it is, not the distance. So I have 5 plus 1 divided by 2, and I have 6 plus 3 divided by 2. And that's 6 divided by 2, that is 9 divided by 2, and we get 3 comma 4.5. So that should be your midpoint. Yeah. Simplify. When we have like terms with exponents, have the same exponent, and then we're going to combine their coefficients. So 3 rad 6 plus 3 rad 6 equals 6 rad 6 minus 3 rad 24. Rad 24 can be simplified. Always look to see if a radical can be simplified. So you have 6 rad 6 minus 3 times 2 rad 6, 6 rad 6 minus 6 rad 6, because these are outside, and you get 0. These are like terms, combine their coefficients. That's negative rad 6 plus 2 rad 2, and that would be our answer. Can't simplify those. We're going to distribute. So we get rad 10 times 2 plus rad 10 times 3 rad 2. Rad 10 times 2, the 2 is on the outside, so that stays on the outside. We cannot multiply a radical with a whole number or an integer. Radical only multiplies a radical, so when I multiply a radical on a radical, 3 is on the outside, we get rad 20. As I mentioned, make sure that your radicals are simplified. Rad 20 can be broken into rad 4, rad 5. Why did I choose 4 and 5 opposed to 2 and 10? Because rad 4 is a perfect square. We always want to break up into perfect squares. Why didn't I break up rad 10? Because its factors, 2 and 5, are not perfect squares. So 2 rad 10 plus 6 rad 5. Now, there is no standard form, or at least I don't know of any standard form that has an order for radicals. We again are going to distribute. We have rad 2 times negative 5 rad 2 plus rad 2 times 2. We're going to multiply the radicals. We get negative 5 times 2. Any radical times itself will cancel out the radical, and we'll be left with the number. Plus 2 rad 2. We get negative 10 plus 2 rad 2. Now, standard form, yes, the constant should always go first in front of the radical. So we have something called rationalization. Rationalization, we are not allowed to leave our answer with a radical in the denominator. We cannot leave an answer with a radical. So you can't leave it as 1 over rad 3. That's not allowable. So we would need to rationalize it. Well, what would get rid of? What could I multiply to get rid of a rad 3? Well, a rad 3 will get rid of a rad 3. And if we want it to be equivalent, I need to make this a value of 1. So whatever is in the denominator needs to be in the numerator. So we get rad 3 over 3, because rad 3 times 3 will give us 3. Now, we can leave this as our answer because it's rationalized. The radical can be in the numerator. So how do we deal with that with this? Well, this is a little bit more complex because we can't just multiply by rad 5. Yes, it gets rid of that, but because there are 2 terms here, we would need to multiply it by that. So we would end up with that. And that didn't help us. It just moved the radical from that term to this term. So multiplying by just the radical that we see is not how we do it. The way we do it is we multiply by its conjugate. What is the conjugate of 2 minus rad 5? It would be 2 plus rad 5. And what we do to the numerator, we have to do to the denominator. So this is a parenthesis, so we're going to multiply that times both of the terms. We get 2 rad 5 plus 5, because rad 5 times rad 5 would leave us with 5. Now, we need to remember that these are conjugates. What happens when we multiply conjugates? Well, our inside and our outside cancel. And we're just left with our firsts. Our first times our first, which is 4, and our last times our last, which is negative 5. 2 rad 5 plus 5 cannot be combined because one's a number, one has a radical, and 4 minus 5 is negative 1. You can leave that as that. I don't like that. I would never leave 5 over negative 1. I would always move the negative up to make it negative 5. So I would take this negative and move it up. And there are 2 terms, so my answer must be, I'm going to put that negative to both of the terms. Negative 2 rad 5 minus 5 would be the only answer that I would accept. Let's see what your Marymount answer key says. Yes, they also agree. Very good. So we have radicals. We can't combine those. We can't add them because they're unlike terms. So we're going to multiply by its conjugate. Rad 5 minus rad 3. What we do to the numerator, we have to do to the denominator. Let's multiply that to both of them. So we get 5 rad 5 minus 5 rad 3. And remember our inside and outsides of conjugates. So we have rad 5 times rad 5, which is 5. And then we multiply our lasts, which is negative 3. So 5 rad 5 minus 5 rad 3 over 2. Solve each equation. Remember to check for extraneous solutions. Okay, so how do we get rid of that radical? We have our variable inside the radical. We got to get rid of it. So let's square it. Square it. 16 equals negative 2 minus 6x. Let's add 2. We have 18 equals negative 6x. Divide by negative 6. Divide by negative 6. We get 9. Oh, we get negative 3 equals x. Now, they say check for extraneous. So we got to make sure that when we plug it in, because we can't take square root of a negative. That's what we're protecting against. So let's plug it in. We get negative 2 minus 6 times negative 3, which gives us negative 2 plus 18, which gives us square root of 16, which equals 4, which equals my thing. So my only solution is negative 3. We like that. Good. Simplify each expression. We're going to factor. Oh, well, hello. We don't have to factor. We should factor, but notice those are the same. So they cancel. You're left with 7 over 2. Oh, I don't know if you can hear the police. Hopefully all is good here. So here we are going to factor this. We get x minus 6 over, let's factor out a 3. We get 3 minus x minus 8, x minus 8, and x plus 6. So what cancels that? And we're left with x minus 6 over 3 times the quantity x plus 6. They do not cancel, and you get this. This program also is weak because it doesn't really have too many things that can cancel. It's very limited. I've never really liked it. All right, now we're adding rational terms. Uh-oh, more things. I think somebody went down in church maybe. Here comes some more fire trucks and stuff. So the first thing, we need to find a common denominator. So I'm going to factor that denominator first to find out what the common factor is. So that is a tough common factor. All right, so my common factor is going to be 12v times v plus 8. Wow. Now, most of you aren't going to be able to see what the common factor is. I'm going to continue on. So what is this denominator missing? That's going to be 5 times 4v. And what is this denominator missing from this? That is missing a, so we have 3 times, 3 times 3v plus 8. That's going to give me 20v over plus 9v plus 72, all over 12v times the quantity v plus 8. We're going to combine like terms, so that gives me 29v plus 72 over 12v v plus 8. It'll be interesting to see if that's the answer. I did that relatively quickly, so maybe you didn't see what I did, but it's correct. So when we find common multiples, least common multiples. So if we have a number like 16x squared and 24x to the third, we're going to find the prime factorization. 2 times 2 times 2 times x times x. And 24 is going to be 2 times 2 times 2 times 3 times x times x times x. I've gotten so good at it that I can do it in my head. So when we look for the LCM, we look for what they have in common. First, what do they have in common? They have a 2 in common. They have a 2 in common. They have another 2 in common. They have an x in common and an x in common. And then the L represents the leftovers. What's left over? A 2 is left over, a 3 is left over, and an x is left over. So my LCM is going to equal what they have in common. They have 1, 2, 3 2's, an x and an x, and then they have a 2, a 3, and an x left over. So I'm going to multiply all those numbers, which is 8 times 4, 6 times 8 is 48. And then I'm going to multiply the variables, x to the third. That is the LCM between these two terms. So that's what I did here. I looked at this. I have 3 times the quantity v plus 8. The prime factorization is 3 times v plus 8. Can't break up the v plus 8. And then I have 4v, which is 2 times 2 times v. So if I'm going to find the LCM, what do they have in common? They don't have anything in common. This v is not in common with that because it's attached to the 8. So what is my leftovers? My leftovers are going to be a 2, a 2, a 3, a v on the outside. So that's 4 times 3 times v, which is 12v, and then my v plus 8. So that's how I got my 12v times the quantity v plus 8. And then how did I go from here to here is I found equivalent fraction, or excuse me, how did I go from here to here? I took my 5 over 3v plus 8 and I wanted to find the equivalent fraction to that, what numerator would have that denominator. So I ask, okay, what did I multiply this to get this? What's it missing? It's missing 4v. So I'm going to multiply the numerator, and that's how I got 20v. And then I did the same thing with this, with that denominator. So I have 3v over 4 equals 12v, v plus 8. What's this missing? That's missing a times 3v and v plus 8. So I'm going to multiply by 3v, v plus 8, which gave me, oh, did I make a mistake? Ooh. Oh no, there's a 4v. Sorry, there's a v there. There's a v there. That wasn't blue. There's a v there. Sorry, that's 4v. Oh, there's a 3 up here. All right, sorry. I rewrote that, wrote that incorrectly. So that's missing a 3. It's missing a 3. So that, and I feel like I've made a mistake here. 3 over 4v, 3 over 4v equals 12v. So I'm missing 3 and v plus 8. 3 plus, that's 9. V plus 8, 9v plus 8. Yeah, oh, there it is. 9v plus 8. That's good. All right, I did it right. Okay, so I think this is the last problem. Common denominator is going to be 6 times x minus 3. 6 times x minus 3. Prime factorization of 6 is 2 times 3. Prime factorization of x minus 3 is x minus 3. We can't break that up. LCM, anything in common? No. So all of these are leftovers. So that's where I get my 6 times x minus 3. Now I'm going to find equivalencies. What's this missing to go this? X minus 3. So this is going to be 4x times x minus 3. And what is 3 over x minus 3 missing from 6x minus 3? It's missing a 6. So we get 18. And we're going to, we have like denominators, so we can combine their numerators. We're going to multiply that out. That's 4x squared minus 12x plus 18. Now, I'm going to look at that numerator and I'm going to see if I can factor it. First of all, I can factor out a 2. So I can pull out a 2, that's 2x squared minus 6x plus 9 all over 6 times x minus 3. So first thing I see is I can cancel those 2 and the 6, which makes 3. So I can turn this into 2x squared minus 6x plus 9 over 3 times the quantity x minus 3. And now I'm going to see if I can factor that. So is it in standard form? Yes. Is there a common factor? No. Is it a special case? No. A times C. 2 times 9 is 18. 1, 18, 2, 9, 3, 6. Signs are the same, both negative. Negative 19, negative 11, negative 9. None of those equal my middle, which was negative 6. So this is simplified. Woo! All right, that's just part 2. I skipped part 1. But you can look at part 1 if you want, or you can go back to part 2. Good luck.